Started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be talking about lists and tuples in Python. But before we get into lists and tuples, we need to define two words, containers and sequences. Containers are any objects in Python that hold references to other objects. These objects can be any type and can include other containers. And they don't necessarily impose an order or indexing on their elements. So some examples would include sets, lists, tuples, strings, and dictionaries. The other word, sequences, defines a specific type of container that holds items in a defined order. So sequences are a specific subtype of containers that impose an ordering. And you can access the items in the sequence using some sort of index, like we saw with strings. Some examples are lists, tuples, and strings, and all of these are containers that have items in a specific order, which makes them a sequence. So what are the differences between lists and tuples? They've come up a few times in the course so far, and we have seen examples in our textbook, and they may seem pretty similar. They're both types of sequences, and they both store or reference objects in a set order, and we can access both through some type of index. The big difference between these two are mutability, and we have talked about mutability a little bit previously in the course, and this refers to can that object be changed after it's been created. Lists are immutable. This means that after we create a list of objects, we can change what objects are in that list. We can add more objects, we can remove objects, we can swap objects around, and we can change which objects are at set indices. Tuples, on the other hand, are immutable. That means they can't be changed after they're created. So we can never add a new item to a tuple, we can't remove an item from a tuple, and we can't change what items are at set indices in a tuple. They both have set methods and functions that we can use to interact with them that we'll be taking a look at later in this video. But there are also slight performance differences. Lists have a very slight overhead because they have to maintain that mutability. Tuples, on the other hand, are slightly faster because they don't have to worry about that. This also affects memory efficiency. Again, lists have a slight overhead because they can be dynamically resized, whereas tuples are slightly more memory efficient. In most cases, this won't make a big difference, but if you're creating a program that processes thousands or millions of lists or tuples, then it could start adding up. So in general, we want to use lists when the data needs to be modified or added to or subtracted from. Whereas if that organization of data or that collection or sequence of data never needs to change, then you want to use a tuple. So we're going to get started talking about lists. These are the mutable sequences. So how do we create a list in Python? Well, as I said, lists are mutable ordered sequences of objects. So that means we're going to have to define what objects are in that list. And lists can store multiple different data types, even in the same list. So things like integers, strings, floats, as well as even other containers. So lists can contain a tuple, or lists can contain other lists. We'll talk more about that kind of nesting in another video. Lists are defined using square brackets, the same sort of brackets that we see when we're indexing strings. Let's take a look at an example. Here we have a few different types of lists that we'll go through. The first one is a list named numbers, and it has the elements 1, 2, 3, 4, and 5. All of these are integer objects, and they're in this specific ordering. Next is a list of strings called fruits, and it contains 3 elements: apple, banana, and cherry. Each one of those are strings. Next is mixed, and this is an example of a list that has multiple different types. It starts with the integer 1, then the string apple, then the floating point number 3.14, and then the Boolean value true. Lastly, we can create an empty list just like this, 2 square brackets with nothing in it, and this is a list that has no elements. Because it's mutable, this could be useful because we can add to this list. So let's take a closer look at this specific list named mixed. So when we're thinking about how this works in terms of the computer's memory, mixed, like other variables, would be a reference to some object in the computer's memory. In this case, because it's a list, is going to be a list object, which is a block of memory. And in each one of these blocks, there's going to be another reference to another object. Remember, lists are collections of objects. In reality, that means they're collections of references to other objects. So in this case, the first block would have a reference to the integer object 1. The second would have a reference to the string apple. Third would have a reference to the floating point object 3.14. And the last would be a reference to the Boolean object true. For the sake of keeping things simple, in these slides and examples, I'm going to just represent this as the numbers being in these boxes. But keep in mind, these are references to objects still, and that is important when we start getting into nested lists. So how do we reference or access these different elements of a list? Well, just like we saw with strings, which are another type of sequence, we can use integer index values to access specific elements of a list. For example, this first element 1 here would be accessed through the index 0. Just like with strings, these indices start at 0 and go to 1 less than the number of elements in the list. The second value, apple here, would be accessed through index 1. Then the floating point value 3.14 would be index 2, and then the last value true would be accessed through index 3. So to quickly summarize that, lists are indexed the same way we index strings and other sequences, using those square brackets with an index number inside. And you can see on the screen now we have an example. This example uses that same mixed list, but now we've added a few different print lines that access the individual elements. So here we can see the different indices, and 0 would be for the first one, 1. 1 would be for apple, 2 would be for 3.14, and 3 would be for true. So the important thing here to remember is that just like strings, list indices start at 0 and go to 1 less than the total number of elements in the list. So what would this output? Well, we can see that here now. And it's pretty much what you'd expect. Accessing the first element at 0 in mixed gives us 1. Then 1 would be the second element, which would be the string apple, and so on for 3.14 and true. Also, just like with strings, we can use negative indexes to access the list elements in reverse order. So bringing back our mixed list here, we could also access the same elements using a negative index. So -1 would be the last element in the list, -2 would be the second last, -3 would be the third last, and so on. Keep in mind that this starts at -1 and not 0, because you can't have -0. So it's a little bit different than when we're accessing it in the forwards direction. Now let's take a look at that example again, but using negative indices. So in this case, we're getting the exact same results, except in reverse order, because we're starting with the first print of -1, which means we're accessing the last element in the list. Then -2 for the second last, -3 third last, and -4, which would be the fourth last, which in this case is the first element, because there's only 4 elements in this list. So we did mention that lists were mutable, meaning that we can change what elements are in a list. This is a bit of a new concept because previously with the sequence we were using, which were strings that stores characters, strings were immutable, meaning we couldn't actually edit the values in the string without creating a new string. That's not the case for lists, and we can edit them without creating a new list. The way we do this is again with the square brackets and with the assignment operator. Let's take a look at an example. Here we have that mixed list again, but now we're going to make some changes. So this is going to define our list. It initializes it and sets it up with the values 1, apple, 3.14, and true. And in the computer's memory, this might look something like this, where we could access these at the indices in the order that they were defined in. Next, we have mixed 0, and we're going to set that to 42. So this is going to look at the list. It's going to look in the indice that we gave, which in this case is 0, and it's going to update that to the value on the right. So just like with other assignments, it evaluates the expression on the right, and the result of that expression is stored in the variable listed on the left hand of the statement. In this case, that's 42, so the first element in the list at index 0 is updated to 42. The next line is similar. It's updating another value in the list. In this case, we're giving index 2, so we're going to update the value at index 2, which is the third value in the list, and we're going to set that to the floating point value 0.1234. The next line is very similar, except now we're using a negative index, and that's completely allowed. Remember, we can also access this list's elements with a negative index, which starts at the end of the list in reverse order. In this case, we're saying index -1, which is the last element in the list, and we're going to update that to the string value duck. The very last line of this code is simply going to output the list. And luckily for us, Python can print lists without us doing anything special. We'll get an output that looks something like this, which is a representation of the list in the console. So in this case, we can see the value 42 because we updated it. Apple remains the same because we never changed that value. 0.1234, which would be at index 2, which we updated. And the last index, which would be index 3 or -1, is set to the new value of duck. So one common error when working with sequences like lists is trying to access a non-existent element. And this may be something you've already experienced with strings because they're a type of sequence and we index them the same way. So when you attempt to access an index outside the bounds of a sequence, Python will raise an index error. This means it's always important to understand and be aware of how large your sequence is, because you don't want to go outside the bounds of it. Let's take a look at a bad example where we do this and cause an error. So here we have a fairly simple list called fruits, and it stores 3 strings: apple, banana, and cherry. The next line is the problem. Here we're trying to access a specific element from the fruits list. But look, the index is 5. The issue here is there is no index 5. There's only 3 elements in this list, 0, 1, and 2. So there is no index 5. That means if we were to try to run this code in Python, we would get an index error that looks something like this, that says list index out of range. And the same sort of thing can happen when you're using negative indices if you go too far negative, to go beyond the start of the list. So again, it's always important to be aware of how big the list is. And you can find that using the length method that we've seen with strings. And that will come up later in this video as well. The next important topic we need to cover about lists is what happens when you make a copy of the variable that seems to be storing a list. Well, in reality, that variable isn't storing the list. It's storing a reference to the list. So when we assign the value of a list variable to another variable, we're not making a copy of that list, we're making a copy of the reference. That means the second variable is going to point to the same list. It's not actually copying the values. This has some fairly important implications when we're dealing with variables that have references to the same lists. It can affect what happens when we modify a list value. Let's take a look at an example because this might be a little bit confusing. So right here we have a fairly simple example where we're creating a list and then we're making a variable that has another reference to that same list, making a few changes, and then seeing what happens. Let's trace through this and get a better idea of what's going on. So in the first line here, we simply define a list called myList. And it has 3 string values: cat, dog, and duck. And of course, we can access these at the typical indices, which would be 0 for cat, 1 for dog, and 2 for duck. The next line is where things get a bit more interesting. Here we have a variable called another list, and we're assigning it the value of myList. But remember, the value of myList isn't a copy of that list. It is a reference to the list. So this line doesn't make a copy of my list. Rather, it makes another list also point at the same list. Let's see what happens when we start modifying these lists. So the next line simply prints out a copy of my list before we make any changes. This would be what you'd expect. It's going to have cat, dog, and duck. The next line, we are making a change to another list. We're setting the 0 index, which is the first element of the list, to aardvark. And what this does is it changes the list, the first element, to aardvark. But keep in mind, both of these variables, my list and another list, are pointing at this same list. So this change affects both lists. The next line, we're changing the index 2 of my list to have a value of zebra. Right now it has duck, so this line would update it and change that to zebra. Again, because both of these are pointing at the same list, this affects both lists. So when we get to the lines where we print this out, we can see that my list and another list have the same updated values. Now they have aardvark first then dog, and zebra. And these changes, even though they came through a specific list variable, affect both lists. So how do we actually make a copy of a list where we copy all the values as well, so the lists no longer are connected together? Well, the key is the list function. And this is another one of those type functions that we've seen. The other ones we saw were int, float, and string, and those all converted another type into their type. The list function's no different. It tries to convert different types, that at least are compatible, into lists. Typically, this is other sequence types or other containers of some kind. But it also has another feature that's important to us. When a list is passed to the list function, it creates a new shallow copy of that list. That means it copies all of the values in the list and creates a new list, rather than just making a new reference to it. By shallow copy, this is a bit complex, but it means that we're only copying the values in the first level of the list. In another video, we'll talk a little bit about nested lists, and just keep in mind for nested lists, this is only going to copy the values in the first list. Other lists further on or at deeper levels in the list aren't going to be copied. When other data types are provided, lists will attempt to create a new list based on that type if possible. So, for example, if we were to give it a string, which is a sequence type, it would result in a list of characters. For each character in the string would get a new element in the list that it produces. For example, ABC and a string would produce a list with the character A, the character B, and the character C in the same order that they're given in the string. Let's take a look at another example. And this is the same code that we saw before, except with one change. And that is we're using the list function to make a copy of the list rather than making a new reference to the list. Let's take a closer look. So once again, the first line is exactly the same. All it's doing is defining a new list and initializing it to these three string values, cat, dog, and duck. The big change comes in the second line. Here, instead of making a new reference to my list, we're making a new copy of it. So that means in the computer's memory, there's a whole new block of memory, and it has references to these objects. This means that these two lists will work independently. So when we start modifying values, such as on this line here, where we're updating the value at index 0 to addvark, this now is only going to affect another list. So instead of updating both, it only updates the reference in another list. So this means that the first element of another list is now addvark, while my list still has cat as the first element. Similarly, if we update my list at index 2 to zebra, this is only going to affect my list now. These lists are completely independent now. So if we were to output these results, we can see that the last element of my list is zebra and the first element of another list is addvark, but these changes don't affect the other lists. My list still has cat as the first element, and another list still has duck as the last element. So when you're working with lists, especially when you're trying to make a copy or another reference, it's important to understand this concept and which one you're trying to do. If you're trying to make a whole new copy of the list with a new copy of all the values, you need to use the list function to make a copy. If you just want another reference to the same list where both will make the same changes, then you can just do what we did in the last example and assign the value of that list directly to another list. That doesn't copy the list, it just copies the reference. Now we're going to move on to talking about some of the common operations and methods that are built into Python to help support us working with lists. Just like with strings, there's a lot of these operations and methods that provide important tools and help make our lives easier when working with these objects. On the screen right now are a list of some of the most common list operators in Python. So the first operation is the in or not in operator. And we've seen this before for strings, and it does something very similar for lists. It checks if the item X is in that list or not in that list. So in the example we have here, we see 2 in the list that has 1, 2, 3, and it returns true because 2 is in the list of elements that is 1, 2, 3. Similarly, we see 2 not in the list 1, 2, 3, and that returns false because the element is in the list. So the in keyword, when used with lists, checks for membership. Is that element in this list? And it doesn't matter what the order is or how many times it occurs. If it occurs at least once, it's going to return true. Next are the equals and not equals operators. And these do let us test if two lists are equal, but it's important to keep in mind what is an equal list. So for two lists to be considered equal, they have to contain the exact same values in the exact same order. If the order is different at all, it's going to return false, as we can see in the example here, which has two lists, one with the numbers 1, 2, 3, and a second list with the numbers 3, 1, 2. So same values, but in a different order. In this case, when we're checking if they're equal, we get false. Not equals is the exact same idea. It's just checking if they're not equals based on that criteria. So if we were to switch that to not equals, like in the second example, we would get true. The next operator is the slicing operator. And this looks somewhat similar to how we access an element in a list, except it has both a start and an end index, rather than just one index. And what this does is it returns a sublist of the indices between these two values, with start being inclusive and end being exclusive. This sublist is a new copy of the list, but it only contains the values in the given range. So in the example here, we have a list 1, 2, 3, and we have my list using the slicing operator to start at index 1 and go up to but not including index 3. This means the result would be a new list with the values 2 and 3, the second and last elements only. This slicing operator can be quite powerful, and it also accepts you leaving out start or end as long as you have the colon there. If you leave out start, then it's going to default to the start of the list, and if you leave out end, it's going to default to the end of the list. Keep in mind that you can also use this slicing operator on other sequences, including strings, so it is quite powerful. Next is the addition operator, and in reality, this is concatenation just like it is with strings. When we add two lists together, they're concatenated or merged together, and it creates a new list with elements of both lists in the order they were added. So in this case, if we have list 1 plus list 2, it's going to be list 1's elements first, then list 2 elements. And that's going to be returned in a new list. It doesn't modify the existing lists. In the example we can see here, we're adding a list with the values 1 and 2 to a list with only the value 3, and the result is a new list with the values 1, 2, and 3. Again, multiplication works very similar to how it does with strings, in which case it is repetition. It means it's going to create a new list with the values repeated num times. So if you times a list by an integer value, you're going to get a new list, but it's going to be created by repeating that list however many times as in the integer value. So in this example, we have a list with just the values 1 and 2, and we're timesing that by 3. So this creates a new list. It doesn't modify the existing list. And that new list is going to have the values 1 and 2 repeated 3 times. So we get 1, 2, 1, 2, 1, 2. The last operation is the delete operation. And this uses the keyword DEL, which stands for delete. And this removes an element from a list at the given index. So in the example we see here, we have a list with the elements 1, 2, and 3. We're using the delete keyword, and we're saying delete the element at index 1. And when we print out this list, we can see the element at index 1, which is the second element, has been removed, and now we only have 1 and 3. Keep in mind, this doesn't create a new list. This modifies the existing list in place. We're now going to take a look at some of these operations in the Python console, where we're going to manage two lists about some items related to a restaurant or a cafe. Let's bring that up now. Okay, we have the Python console up using PyCharm, and we're going to put in two lists. So the first list is drinks inventory. It's pretty straightforward. It has 3 different items right now: coffee, tea, and juice, and each one is a string. These are going to represent the inventory our little cafe currently has in stock. And we're also going to define a second list, which is going to be the food inventory. In this case, it's going to be a sandwich, a cake, and juice. That's what we currently have in our inventory. And you can see in the console, we can take a look at what variables are currently defined, and we see 2 lists. Both of them have 3 elements. The first is coffee, tea, juice for drinks inventory, and the second one is food inventory, and it has sandwich, cake, and juice. PyCharm will even let you expand this to give you an idea of what is at each index and what the index numbers are. Okay, let's do some stuff with these inventory lists. And the first one is maybe we want to check if something is in stock. So what we can do is, let's say we want to know, is tea in stock? So we'll make the string T. And remember, we can use the in operator to check if an element is in a list. So we're going to say, is T in drinks inventory? And this returns true, because T is indeed in our drinks inventory. It's the element at index 1. And it doesn't matter where the index is, as long as T is in here somewhere, it would return true. We could also see using not in. Not in does the opposite. It returns true only if it is not in the list. So in this case, T is in the list, so it returns false. We can also try something that's not in the list, like is pop in the drinks inventory. In this case, false. And of course, we could store this in a variable. In this case, the results of this in operation are going to be stored in the variable is pop in inventory. And we can see that it is false. We could also use that in an if statement, for example, to check if something was in our list. For example, we could say if T in drinks inventory, then we will print out tea time. And we do get tea time because tea is in the drinks inventory. One thing to keep in mind is that just like with strings, this is case sensitive. So if we change this to T, we're going to get false. Because remember, most things in Python are case sensitive. Okay, the next operation we'll take a look at is addition or concatenation. Remember, this adds two lists together by creating a new list with those values concatenate together. So whatever's on the right-hand side is going to be stuck on the end. So let's say we want a full inventory list. So I'll make a new variable called full inventory. And we're going to set that equal to adding our drinks inventory plus our food inventory. So what this is going to do, it's going to take drinks inventory, which is coffee, tea, and juice, and it's going to concatenate onto the end, sandwich, cake, and juice, but it's going to make a new list. It's not going to update the values of the existing lists. So we can see if we hit enter, and we can see a new list popped up in our list of variables. We can even print that out. And you can see it added what was on the right-hand side to the list on the left-hand side. So if we were to flip this around, we can see they're now reversed. So it does matter what order you concatenate them together, just like it does with strings. Okay, what should we try now? Let's say we want to remove something from our full inventory. Maybe we have too much juice in stock because juice is in there twice now. So let's remove the juice at the end of the list. And the way we can do this is using the delete keyword, or DEL. And we have to give it the index of the element we want to delete. Since the element's at the end of the list, we could simply use a negative index. So in this case, we're saying delete the value or the element at the end of the list, because -1 means whatever's at the end of the list. We could also give it a 2 to delete the juice that's somewhat in the middle of the list. Whatever index we want is going to be removed. We'll remove the one at the end. So after we ran this, you can see over here that the list was updated to remove juice, but we can print it out again to see that in the console. And we removed the last element of the list. So that's one great thing about lists. They're mutable, so we can add and remove elements wherever we want. Okay, what should we try next? Let's see if these are the same. Is the drinks inventory the same as the foods inventory? And we can check that using equals equals. So in this case, it's going to check, are these lists the same? But remember, it can't just be the same. It has to be the same elements in the same order. In this case, they don't even have the same elements, so we get false. These are not the same inventories. We could also try not equals. It's going to do the same sort of check, but in the opposite way. So it's going to check, are these two lists the same with the same elements in the same order? If they're not the same, it's going to return true. Otherwise, it's going to return false. So in this case, they're not the same. They don't even have the same elements. So we get true. Now, one last thing we can check out is doing a repetition. So let's say we want to make the value cake many times because we want to eventually add this to our inventory. We have a lot of orders for cake, so let's order some more cake. So we're going to make a new list called restock cake. And what we're going to do is we're going to make a new list here too that just says cake. So this would be a list with a single element, which is the value cake. And we can see that we have the variable restock cake with one cake. But let's say we need a lot of cake. So what we can do is we can say restock cake times 3. And what this would do is it would repeat that value 3 times. So this would create a list of cake, cake, cake. And you can see restock cake has been updated to cake, cake, cake. We can also print that. And now let's say we wanted to add this to our full inventory to get a final inventory. So what this is going to do, it's going to take our full inventory, which currently has sandwich, cake, juice, coffee, and tea, and it's going to add our restock cake inventory, which is just cake, 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 and then it's going to create a new list and store that in final inventory. And we can print that out. And you can see it added cake, cake, cake onto the end of our inventory list. We can also try out some string slicing. So we have our final inventory list that we just created. And let's say we just want the first 3 elements of that list. Well, what we could do is we could create a new list called first 3. And we'll say we're going to start at index 0, which would be sandwich. And that's going to go up to, but not including index 3. So sandwich would be 0, cake would be 1, and juice would be 2. We can output the value of first 3. And you can see it made a new list that's completely separated from final inventory, and it contains sandwich, cake, and juice. We also do different areas in the list. For example, let's say we wanted coffee, tea, and cake. So coffee would be 3, tea would be 4, cake would be 5, and we only want 1 cake, so we'll go to 6. And we'll just output this to the console. And you can see we got coffee, tea, and cake, because coffee was at index 3, and index 6 is the second cake, but remember it goes up to, but not including this one. So we get coffee, tea, and cake. The other thing we can do with splicing is leave out the start or end value. For example, if we go with 3 as our start, and we leave out the end, it will go 3, the third element, all the way up to the end of that list. So in this case, element 3 would be 0, 1, 2, 3, and we get coffee, tea, cake, 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 which we do. Coffee, tea, cake, cake, cake. We can also go in the opposite direction. And let's say we want not to include all the extra cakes. So we have 0, 1, 2, 3, 4, 5. This would be 6. So we want to go up to, but not including the second cake. And since we didn't put in the first value, it's going to go from the start of the list all the way up to, but not including index 6. So we get it without the repeated cakes. Another common thing you'll see if you're looking at Python code online or in our textbook is using a slice like this with nothing on the left or the right. And this seems somewhat useless. It's just going to return the whole list from the start to the end. But one important feature is that it makes a copy of the list. So this gives us another way to copy a list without using the list function. So this would return the exact same list, but it's a copy of the list. So if we wanted to assign that, we could say list copy equals this. And we can see that this is a different list in the computer's memory. So if we were to say list copy, and we'll update the first value to pop, we can see over here that it only affected list copy. It didn't affect final inventory. So another way to copy a list. Okay, let's continue on with the slides. If you'd like to try this out for yourself, example 6.2, which you can find a copy of on the Learning Management System, has some of the commands you can try out. I recommend trying this in the Python console and running one line at a time so you can see how it actually changes the lists and variables. Now we're going to move on to list methods. Just like how strings have methods associated with them in Python, lists have their own set of methods that are specific to lists and make it a little bit easier to work with them. So let's go through some of these now. The first method we see on the screen is append, and this simply adds whatever argument you give this method to the end of the list. This doesn't create a new list, it edits the list in place. So in the example we see here, we have a list with 5 and 8. If we append 16 to it, the value of 16 is added to that list. So it does modify the list, it doesn't make a new one. Similarly, we have the method insert. It's the same idea as append, except it lets us insert it to a specific location in the list. So whatever index we give for I, the value x is going to be inserted before that index. So look at another example, as we have on the screen right now. We have a list with the values 5 and 8. We're going to be inserting at index 1 the value 1.7. Since index 1 is the second element in the list, this inserts it before what is currently at index 1. Currently at index 1 would be 8, so this puts 1.7 before the value 8. The next method is remove, and this removes the first item from the list with the value x. This works a little bit differently than that delete keyword that we saw, because this is deleting based on a value rather than based on an indice. So this will search the list, and the first value it finds that's equal to x, it will remove that value. In the example we see here, we have a list with the values 5, 8, and 14, and we're using the remove method to remove the value 8. So it goes through the list, and it finds the first occurrence of 8 at index 1, and it deletes that element. And again, this is modifying the list in place, it's not making a new list. The next method is pop, and this can be used in one of two ways. You can either provide it no arguments, in which case it's going to remove the element at the end of the list, or you can provide it an index. If you provide an index as an argument, it will remove the element at that index. Pop also does something special, however. It also returns the value. So this method returns the value that it removes after it removes it. And this removal is done in place, meaning it modifies the list. We can see in the example here, we have the values 5, 8, and 14 in my list. And when we call pop on this list, it removes the value 14 and it returns that value. So the variable val, VAL, is set equal to 14 in this case. Next method is index. And what index does is it returns the index of the first item in the list with the given value. In the example shown on screen now, we have that same list with the values 5, 8, and 14 stored in the variable myList. When we call index on myList with the value of 14, it's going to search the list from the left to the right, from the start to the end, and it's going to return the index of the first value 14 it finds in the list. In this case, 14 is the last element of the list at index 2, so it returns the index value 2, and that is printed to the screen. Keep in mind that when you're using the index method, if you give a value that's not in the list, Python will raise a value error. So it can be good to check that that value is in the list, using the in keyword, for example, before you use the index method. The next method is count, and this works just like the count method for strings. It counts how many times a given value occurs in a list. So in this example, we have a list with the values 5, 8, 5, 5, and 14. And if we use the count method to count the number of times the value 5 occurs, we would get a 3. If the value doesn't occur in the list, we would get a return of 0. The next method is reverse, and this reverses the elements in the list in place. It doesn't create a new list. So for example, if we had a list with the values 14, 5, and 8, if we called the reverse method, it would reverse these, so we have now the values 8, 5, and 14. Sort is a similar method, but instead of simply reversing them, it sorts them by value. So if we have a list with the values 8, 14, and 5, it will sort them by default from the lowest value to the highest value. So in this case, 5, 8, and 14. Let's now try out some of these methods in the Python console. We'll bring that up now. We're going to start by defining a list called waiting list. And this is going to be a waiting list to seat customers in for our cafe again. So we're going to take customers from our list, and then we're going to seat them in this order. So waiting list has now been defined, and it has the values Alice, Bob, Alice, and Charlie. So maybe we want to check if Alice is in our list more than once. We could do that with the count method. So we're going to say waiting list.count. And we want to know how many times Alice occurs in our list. In this case, 2 times. Keep in mind that, again, this is case sensitive. So if we were to use a lowercase a, we would get a different result. So when you're storing values in your list or using count, you might want to consider, should they all be in uppercase or lowercase, so you can match them correctly. Now, let's say Alice is in our list twice, so we want to remove it. We should only have Alice once. So we're going to do waiting list, and we're going to use the remove method. Now, remember, remove edits the list in place, so it's not making a new copy of the list, and it finds the first occurrence of that value. So in this case, it would be right at the beginning of our list, and it removes that. So when we call that, we can see that the value for waiting list has been updated, and the first value, which had Alice, has been removed. You can also print that out. And we can see it's no longer there. Now let's say a new customer arrives, and they want to be added to the waiting list so they can get a table. We can do that with the append method. The append method simply adds whatever value we give it onto the end of the list. So let's add our new customer. And we can see the list has been updated to add that new customer on the end. But now let's say another customer arrives, and they're a VIP, so we want to give them priority in getting a table, and we want to add them to the beginning of the list. Append would add it to the end of the list, but we can use the insert method instead to insert a value at a given spot in the list. So in this case, we want to insert someone at the beginning of the list. The beginning of the list would be the very first element, which would be at index 0. So this will insert this new value right before the beginning. So right now at index 0 is Bob, so this will add whatever value we give it next before Bob in the list, and it will become the new element at index 0. So we'll call this person Eve. And we can see when we print out the list, they have been inserted at the very beginning. And we could insert someone anywhere we want. Let's say we could insert them at index 2. We'll put Dan in the list. And you can see Dan has been inserted at index 2, and that pushes everything back in the list. Now let's say we have a table ready, and we want to take one of the customers. So if we're going in order of this list, that means we want to take the person at the very beginning. An easy way to do this, as well as figure out who we're seating, is to use the pop method. So in this case, we could say first served, and we're going to waiting list, and we will pop off a value. And since we want this at the beginning of the list, we're going to give it 0, which means pop that value out of the list, remove it from the list, whatever's at the very beginning at index 0, and then return that and save it in first serve. So 2 things are going to happen when we call this. It's going to remove Eve, and the value Eve that we removed from the list is going to be assigned to first served. So we can see a new variable has appeared called first serve with Eve, and we can also see our list has the first element removed. Let's print out the waiting list again, and we can see that it's gone. And we can also see first served is currently equal to Eve. Now let's say this person that we added at the end of our list is fed up with waiting, and they're going to leave. So we need to remove them from our list. Well, we can use the pop method to do that again. And remember, if we don't give pop any argument at all, it simply removes the value at the end of the list. And since we're typing this into the Python console, it's going to return the name of that customer into the console, and it's also going to update the list to remove that customer. So we got the last customer in the list, and we can also see that the list has been updated to remove the last element. So pop with no arguments removes the last element, pop with a specific index removes that element at that index. Okay, let's continue with the slides, and take a look at some of the built-in functions. Before we get into those built-in functions, I do recommend trying this out at home. Here, example 6.3 has similar steps to what we just did in the Python console. I recommend trying these different lines out in the Python console one line at a time, so you get an idea of how these work. This can help a little bit more than just running the program, as you can see how the list changes after each line is executed. Okay, onward to built-in list functions. So Python has a number of functions that work really well on lists and can be quite helpful. These functions often work on other sequences as well as other data types, but for now we're going to concentrate on what they do for lists. The first function is the length function, or len, and we've seen this before with strings and some other types, and what this does for a list is simply return the number of elements in that list. So for example, we have a list over here with 2, 3, and 1 in it. That's 3 elements. And when we call length on that list, we get a return of 3, which is printed to the screen using print. If we have an empty list, which is just 2 square brackets with nothing in it, then the return would be a 0, meaning there's no elements in that empty list. The next functions are max and min, and they do pretty much what you'd expect. They search through the list, and they return either the maximum or the minimum value. In the example here for max, we have -3, 5, 25, and 0 in a list, and it returns 25, which is the largest value. For min, we have the same list, and it returns -3 because that is the lowest value. A similar function is sum. And again, this does pretty much what you'd expect. It adds all the values in a list together and returns the result. Just make sure the values in the list actually can be added together. In this case, we're using -3, 5, 25, and 0, which returns 27. The last two functions are for Boolean comparisons. So what all does is it checks the list, and if all the values are equal to true, it returns true. Otherwise, it returns false. But one interesting thing to note is that it considers any value that's not equal to 0 to be equivalent to true. So you can use this for things that aren't just Boolean values. So in the example given here, we have a list with the values 1, 2, 0, and 3. This is going to return false because 0 is equivalent to false. So that means at least one of these values is false, so it returns false. In the second line, we have a list with the value true, as well as the value 10. 10 is going to be considered a true value because it's not equal to 0. So since both of these are true, it returns true. Any is the same idea, except it returns true if any of the values in the list are true or not equal to 0. So in this first example, we have the values 1, 2, 0, and 3 again. In this case, the 0 is treated as a false, but since we're using any, as long as one of these are true, it returns true. And 1, 2, and 3 are all considered to be true values because they're not equal to 0. In the second example, we have 0 and false. Both of these are false, so none of them are equal to true, so we get a return of false. So both of these, all and any, can be useful when we're dealing with lists with Boolean values, true or false values. While max, min, and sum are more useful for values that can be ordered or added together. So let's now take a look at an example that's using a number of these functions. And let's try this out in PyCharm just to get a better idea of how it's working. Here we are in PyCharm, and we have the example open. Let's go through what this is doing. So the first lines here are just simply creating a new list that has no values in it. So we're initializing an empty list with nothing in it. And we're going to use this list to input numbers that are input by the user. Each time the user inputs a number, we're going to add it to this list. Here we have a while loop, and it is going to run forever because we're setting the condition to true. So this will only stop when we reach a break statement. Inside this loop, we're asking the user to input a number. We're going to assume that they do put in a valid integer. This would break if they put in something silly like the word duck. And if they put in a negative integer, we're going to break out of the loop. Otherwise, if it's positive, we are going to append that value to our list numbers. Remember, the append method adds that value to the end of the list. So we're going to keep asking the user for numbers, keep appending them to the list until they eventually input a negative number and we break out. When we break out of the while loop, we then start down here and we run these print statements. The first one's just going to be a copy of the list. Then we're going to run the length function on it, the max, the min, the sum, and then sum divided by length. Okay, I'm going to add a breakpoint down here, so we'll pause after the loop before we start printing things out, and we'll run this in debug mode. Right now it's asking for numbers. This is this point in the code where we have that input line. So I'll input a few numbers, 10, we'll say 5, maybe 100, a 0, and a 42. Now I'm going to put in a negative number. It could be any negative number, but I'll go with -1. And what this will do is it will trigger this if statement and get us out of this while loop. And we reach the breakpoint, so the program pauses because we are in debug mode. And we can take a look at what the current value of some of these variables are. The most important one is the numbers list. You can see we have the values 10, 5, 100, 0, and 42. These are the numbers I input because they are being appended each time to our list of numbers. Note that -1 is not stored in the list, and the reason for that is this if statement triggers before we append -1 to our list. So as soon as we get to that break, we exit out of this while loop before we actually append the value -1. So now we're down here and we're going to go through each one of these print statements one at a time. And the first one is simply going to print out the values currently in numbers. Move to the console, and we can see we get just the values that were in the list, probably what you expected. Now we're going to print out the return of the len function, which is length. You could probably guess what this is going to output, and it is 5. That's because there's 5 elements in our list. 1, 2, 3, 4, and 5. The next function is max, and it's going to find the maximum number, which of course is 100. Next, we're calling min on numbers. In this case, we get 0 because that is the lowest number in our list. Next, we're going to do sum, which takes the sum of the numbers. So 10 plus 5 plus 100 plus 0 plus 42 is 157. And lastly, we're going to combine 2 of these functions together to find the average of the numbers. So the average is the sum divided by the number of numbers. We're going to get sum using the sum function, and we're going to get the length, or the number of numbers, with the length function. And we can see this gives us the average of 31.4. So these can be quite useful functions to use with our lists, especially the length function, as that will come up when we start iterating over lists and using them in a for loop. Okay, let's switch back to the slides. And we're back to the slides. In the slides, I do have another example of running this program, but I highly recommend that you try it out yourself. The best way to learn is to actually try these programs and explore them in things like debug mode. Maybe try changing a few lines. Next, we're going to take a look at a more complex problem using lists and some of these operations, methods, and functions. So in this case, we want to create a program that allows the user to track a to-do list. So the to-do list is going to contain a number of different tasks that the user supposedly has to complete. The user should be presented with a menu that allows them to select from 1, printing out the current to-do list, 2, adding new task to the to-do list, 3, removing an existing task from the to-do list, and 4, exiting the program. When the program exits, it should output the current tasks in the to-do list. Add air checking to check if the list is empty when printing out menu option 1, and check that a task exists before removing it, menu option 3. Then check that the menu input is valid. So let's code this one together in PyCharm. Here we are in PyCharm, and I have started with a comment just explaining the text of the problem. Same thing we just saw in the slides. So the first thing we're going to need to do is we're going to have to create a list that's going to store this to-do list. We're going to call that list tasks, and we're going to start it off as an empty list. So to start with, this list isn't going to contain anything until the user adds new tasks to it. Since we're going to have a menu system that's going to repeatedly ask the user for input over and over again until they exit by selecting that menu option, we are going to use a while loop that runs forever until a break statement is given. There are other ways you could code this, like you could check the value that the user inputs and exit based on that. But to keep the code a little bit simpler, we're just going to use a break statement. So the first thing we're going to want to do is we're going to want to print out that menu to the user and allow them to select from the options. I'm going to fast forward while I type that in. written the lines to print out the menu as well as take input from the user and store that in menu item. Right now, this code doesn't do much. It's just in an infinite loop, so it's just going to keep writing this out over and over again and basically ignoring what the user selects. But we have more to add. Before we do that, though, we should go over how this works. Just as a quick review, these escape characters put in a special character. So /n is going to put in a line break, so that will give us an extra line before each time this menu is printed, which makes the output look a little bit nicer and easier to read in the console. /t is going to input a tab character, which is going to indent each one of these menu options. Again, this is mostly for formatting. Now, one thing you should do when you're working on your assignments or code in real life is that you should test your code as you go. Don't wait till you've written the whole program to test it. You should test it as you're programming it. So we're going to test this out, even though it doesn't do much yet. And we can see some output here. So these lines here are being produced by these print statements. And that's pretty much what we'd expect. We have the tab characters there, and we have that extra line break to get us down a line. And we can see the input is asking for input. And since we haven't coded the rest of the program yet, it doesn't really matter what we input. It's just going to keep asking for values. Even if we put a 4 in, it's not going to exit yet. So this is doing what we want, but we just haven't finished the program yet. We want this sort of loop structure that's going to keep looping, asking the user for input. Now we need to add, what are we going to do with that input? Since there's no way to exit this yet, we have to stop it manually using the stop feature here. And we'll just close that for now. So our next task is going to be handle each one of these menu cases, 1, 2, 3, and 4. And a good way to do that is with an if statement. So we're checking if the menu item equals 1. We have to have the 1 in quotes because we never converted it to an integer. In this case, that's fine. That means we won't get an error if it is not an integer value like duck. We're just going to compare and see if it is the string. So if they input a 1, we want to output the values in the list. So that is as simple as saying print and your current tasks, and we'll include the tasks. Remove that space, since print is going to put 1 there for us. Now, this will work, but the problem is it wanted us to check to see if the list was empty before printing it out. So how could we do that? Well, we do have a useful function that we saw called length, or len. And that is going to check how long the list tasks is. If the list has nothing in it, it would return a 0. So we're saying if it's greater than 0, there's at least something in the list. We're going to print out the task list. Otherwise, we're going to print out a message just saying there's nothing in that list. So that gives us the option for menu 1, but we can't really test it yet because we don't have a way of adding anything to our list. So we have to code at least option 2 to add a task. For checking if they input a 2, then we're going to handle adding a new task to the list. And to figure out what that new task is, we are going to have to ask the user for some input. So we're asking the user to input a new task. And one thing I'm going to do is going to convert that to lowercase, because if they're all in lowercase, it's going to be easier to remove them. The user doesn't have to worry about getting the capitalization correct. Now we have to add that new task to our list. And we do that using the append function. So this will add whatever string the user input as a new task to the end of our task list. And we can check this out because we at least have a way to add and print the menu right now. So we're getting the list. If we hit 1, there's no task currently in to-do list. That's good. Our check is working. Now let's try adding something. Okay, we're going to put in a new task. In this case, it's going to be do homework. And now we can print out the list and see if it was added. We can see your current tasks are now do homework. Let's try adding another task. Say call mom. And we'll print out the task. So it is working to add tasks, but we haven't implemented the other menu features yet. So now we have to add the other menu features. We'll start with remove task. So if the menu item is 3, then we want to handle removing the task. But first we need to know which task we're removing, so we'll have to ask the user. And we'll say input name of task to remove. And again, we'll convert this to lowercase. So we have the name of the task the user wants to remove, but we need to check if it's actually in our task list. And we can use the in keyword to do this. Remember, the in keyword will check if an element is in a list or a value. So if to remove is in tasks, we know that we could remove it. Or we could say not in if we want to give the error message. So if the task name the user input is not in our list of tasks, we can tell them that it doesn't exist. Let's say error, say the name of the task. So let's use an F string for that. Is not in your to-do list. If it is in the to-do list, then we want to remove it. And we can do that with the to remove. Or sorry, we can do that with the remove method and using it on the to remove value. So this will remove the first occurrence of that in the task list. The other thing we want to do is to be able to actually exit this program. So if it equals 4, we want to exit the loop. We could do that simply by breaking. And then lastly, we could put in an else case in case they input invalid input. And now we can test this out. In theory, we should have added a new case to deal with removing tasks, and the new case to deal with exiting the program, and one to handle any errors in the user input. Let's give this a run. Okay, so what would we like to do? Well, first we are going to need to add a task before we can remove one. Do the do homework. And we'll add another task. Go back column 1. And we'll add one more task. In this case, get some sleep. We can use 1 to print. You can see all of our tasks are in there. Notice that they're converted to lowercase. So we can try removing. First, let's try removing something that doesn't exist. Feed duck. So we get error, feed duck is not in your current to-do list. So let's try removing one that does exist. Let's say we did our homework. And we didn't get an error. And when we print out the task list, we can see that it has been removed successfully. And we can exit. So the only thing left that we haven't implemented yet was just to print out the list again when we're done. So this while loop, when it exits, we know that we've inputted a 4 and we're done. So we could say your to-do list. And we'll quickly test that last line. Whenever you make a change, you should always test. Feed duck. And get some sleep. And when we exit now, we can see that it does print the to-do list. Okay, let's switch back to the slides. And we're back to the slides. So here I have a copy of that program, or at least one that I made earlier that's fairly similar, but it has extra comments added to explain it. I recommend giving this a try in PyCharm or however you want to look through it. It is attached in our learning management system as example 6.5 if you want to try it yourself. Now the good thing might be to just based on the text of this problem, give that a try yourself too, and then compare it with the solution if you run into any problems. So now we're going to move on to talking about tuples. So if you recall from the beginning of this video, we discussed the differences between lists and tuples. And the main one was that tuples are immutable. They're very similar to lists. They're sequences that store lists of objects in a specified order, but the big difference here is tuples can't be edited. So after you define a tuple, you can't change what elements are in that tuple, you can't add elements, and you can't remove elements. They support some of the same methods and functions as lists, however, none that are actually about editing the tuple. So for example, append and remove wouldn't be available for tuples. Now the reason we might want to use a tuple is that they are slightly faster and they're slightly more memory efficient, which could be a big deal if you're processing a lot of data. So if you don't need to ever edit your list, it should probably be a tuple. But if you need to make changes to that list, it needs to be a list. So to reiterate, tuple is a built-in immutable sequence type in Python. Once it's created, the elements of a tuple can't be changed. No modifications, additions, deletions, anything like that. And tuples are commonly used to store fixed collections of items. Let's take a look at the syntax for defining a tuple. So the first line we have here defines the tuple with the elements 1, 2, and 3. It works very similar to creating a list, except we use round brackets. The second line is another way we can create a tuple. In this case, this tuple will have the string values apple, banana, and cherry, but there is a shorthand we can use, which is omitting those round brackets. When we give an ordered list of values like this, without any brackets, square or round, it defaults to becoming a tuple. So now we're going to take a look at some common operations on tuples. And tuples support most of the same operations, methods, and built-in functions as lists, except for those that would modify the value of the tuple. For example, we can access a specific element of a tuple using the same sort of indexing that we've seen with strings and lists. So that is with the square brackets and giving an index number. And just like with strings and lists, indexes start at 0. So in this case, print my tuple at index 1 would give us 20, which is the second element in the tuple. We can also test membership, just like we did with the ind keyword with a list and a string. In this case, we're checking if 20 is in my tuple. In this case, it is the second element, so we get a true. And we can do the same sort of equality testing that we saw with lists. And again, they have to be the same elements in the same order for them to be considered equal. In this case, tuple 1 and tuple 2 have the same elements in the same order, so when we use the equals operation, it returns true. Now, keep in mind, we can't modify tuples. So something like this that we could do with lists, where we try to change the value at a set index, isn't going to work. When we try this, we would get an error with the tuple saying that tuple object does not support item assignment. So keep that in mind, we can't do assignment on tuples. This also means that it's not going to have methods like remove or append. If we try to do this on a tuple, we'll get an error that says there is no method called remove or there is no method called append. Now, one of the things we can do with tuples, and this is also true of lists to some degree, is unpacking. And unpacking is a technique that we use to assign elements of a tuple to individual variables in a single statement. We could do this just with indexing, but this is a bit of a shorthand to keep our code more readable and clean. Let's take a look at an example. Here we have a very simple tuple. It's called point, and it stores the elements 4 and 5. Now what's interesting is this second line here. You can see on the left-hand side, we actually have two variables, when typically what we've seen in the past with assignment is always one variable on the left-hand side. What this does is it takes the values from the tuple in the same order and it assigns them to the variables on the left-hand side. So 4 would become assigned to x and 5 would be assigned to y. If we had more values in the tuple, like maybe we had a 7, and then we could add another variable like z, and then that would get that 7 value. So however many values are in the tuple, we could keep adding variables there, and they would be assigned the values in the same order. Again, we could do the same thing with indexing, but this is a nice shorthand that keeps our code a bit cleaner. So this would print out x equals 4 and y equals 5. Now, the same sort of unpacking can be used for the returns in functions to allow us to return multiple values from a single function. And it does this by returning a tuple with all those values. that we can either pack or unpack with the same sort of unpacking. Let's take a look at an example. Here we have a fairly straightforward function. The idea is this function is going to calculate two statistics, the sum of the tuple as well as the average value in the tuple. We're going to assume the tuple only contains numbers. So the key here is going to be this last line in the function, which returns a value. Here we have a comma. So we're actually returning one value, which is a tuple, that contains two other values. Remember, without the brackets, if we give a list of values like this, it defaults to a tuple. So really what we're saying is this function returns the tuple that contains the value of total and contains the value of average. In this case, with the numbers we have hard-coded here, 10, 20, 30, 40, and 50, this would be a tuple containing the values 150 and 30. Then when we get that result back in our code, we can use the same sort of unpacking to assign these to different variables. So in this case, we're calling calculate stats, and then we're going to assign the returned total to total, and we're going to assign the returned average to average. When we finally print this out, we'll get the total is 150 and the average is 30. So this is a really powerful way where we can return multiple values from a function. The last thing we'll do in this video is quickly summarize the two data structures we've been working with, tuples and lists. When we're defining a new tuple or a new list, the syntax is slightly different. Tuples use parentheses, which are circular brackets, while lists use square brackets while defining them. Tuples also can just omit the parentheses and it will default to a tuple. The syntax for accessing certain elements always uses square brackets for both tuples and lists. Next up is mutability. Tuples are immutable. That means we can't change them, we can't add elements, we can't remove elements, can't swap elements around or change their value. Whereas lists are mutable. They can be modified, we can append new values to them, we can remove values, and we can swap values around as well as change values at a set index. Performance-wise, tuples are generally faster and more memory efficient than lists. Ideally, we should use tuples unless we need to be able to modify that data structure. So in summary, use cases, tuples are ideal for fixed collections that don't change during your execution of your program, while lists are best for dynamic collections that can change. That's all I have for you in this video. In our next video, we're going to be taking a look at how we can iterate or loop through a list, as well as nested lists, and some ways that we can work with lists to make our life a little bit easier. Thank you for watching, and have a great day.